Okay, let's be real. We are absolutely drowning in data these days. It's everywhere, from our business dashboards to the news we watch. But how often do we actually stop and think about what those numbers are really trying to tell us? Today, we're going to dive deep into a skill that's more critical than ever, thinking critically about data. It's all about going beyond the numbers to see the hidden stories and the hidden biases.
You know, this quote right here, it just nails the problem perfectly. We're getting more and more, quote, dashboards that present numbers as facts rather than hypotheses. We've somehow started treating data like it's the absolute final truth. But here's the thing. Every single number should be the start of a question, not the end of the conversation.
And that leads us right into our first big idea, the illusion of objectivity. It's this really comfortable but honestly pretty dangerous belief that data is pure, that it's untouched by human hands. But as we're about to see, that's almost never the case.
The truth is, data is not neutral. It's always an interpretation. I mean, think about it for a second. Every single data set you've ever seen is the result of human choices. Somebody had to decide what to measure, what to ignore, and exactly how to present it. So the big takeaway here is, when you look at a chart, you're not just seeing the facts. You're seeing the end result of a whole series of decisions that were made long before that chart ever got to you.
And if that wasn't already tricky enough, the very next hurdle we have to get over is actually inside our own heads. Which brings us to our second point, our brain's built-in biases. So this table kind of lays out the classic mental shortcuts our brains love to use. And look, these aren't really flaws, they're features. They were designed to help us survive, not to do perfect statistical analysis. You've got confirmation bias, where we just see what we already want to see. There's anchoring, where the first piece of info we get just sticks. Availability bias, where dramatic or recent events feel way more important than they are. And survivorship bias, where we only pay attention to the winners and forget about all the ones that failed. Each one of these, in its own subtle way, is warping how we see the evidence.
Let's just zoom in on the big one, confirmation bias. This is that unconscious pull to find and favor any piece of evidence that supports what we already believe to be true. Now, inside an organization, this is incredibly dangerous. It means an analyst might, maybe without even realizing it, clean up the data or tweak a model in a way that just so happens to justify a decision that's already been made. It looks like data-driven work, but really, it's belief-driven.
And of course, these personal biases don't exist in a vacuum, right? They get amplified by the environment we work in. So on one side, you have authority bias. That's when we might kind of massage our analysis to match what we think the boss wants to hear. And on the other, you've got groupthink, where we all just agree on something to keep the peace and not rock the boat. In both cases, the result's the same. We end up trusting people more than we trust the process.
So, we've got our own biases to deal with, and we've got our team's biases. But there's actually a third layer to this whole problem, and that's the persuasive power of the data itself. This isn't just about what the data is, it's about how it's presented to us.
Just take a look at this, a 5% failure rate versus a 95% success rate. Now, it's the exact same data, but which one feels better? Which one is more likely to get a project another round of funding? The first one sounds like a problem we need to fix, while the second one sounds like a victory we should celebrate. This is what you call framing bias in action. Just the way the data is worded can completely change our emotional response, and because of that, it can change our final decision.
And it's definitely not just about words. The very design of our dashboards is full of these persuasive little tricks, and they're often hidden in plain sight. You know, truncating the axes on a chart to make a tiny little change look like a massive earthquake. Or using selective coloring, red for bad, green for good, to tell us how to feel before we've even read the numbers. These are not just aesthetic choices. They are powerful arguments that can easily lead us to the wrong conclusions. The trick is to start noticing them.
Okay, so the problem is pretty clear. The data can be biased, our brains are biased, and the way data is presented is biased. So, what in the world do we do about it? Well, we need a toolkit. Let's call it the Skeptics Toolkit. This framework here gives us a clear path forward. It's a disciplined way to practice what our source material calls functional skepticism. It all starts with framing the problem, and I mean really asking, are we even asking the right question, or are we just trying to make a metric look good? Then you formulate a hypothesis you can actually test. From there, you scrutinize the evidence. You have to ask, what could this data be missing, or is there another way to explain this? You have to actively hunt for your own biases. And finally, and this is a big one, you have to treat automated models as what they are, hypotheses, not undeniable truths.
Now, it's really important to get this next point. Being a skeptic is not the same thing as being a cynic. This slide makes that distinction crystal clear. Functional skepticism is all about questioning evidence to get closer to the truth. It's driven by pure curiosity. A functional skeptic sees a poll and asks, "Okay, cool, but what's the margin of error?" On the other hand, corrosive denial just rejects evidence to protect a belief. It's driven by defensiveness. A denier sees that same poll and just says, "All polls are fake." As an analyst, your job is to be that curious skeptic, not the defensive denier.
So this all leads to a really crucial point. As AI and automation get better and better at doing all the raw number crunching, our value as humans has to shift. The analyst's role is no longer to out-calculate the algorithm, but to out-reason it. We're the ones who have to step back and ask, are we asking the right questions? Are our assumptions actually valid? Are we interpreting this logically? That is a skill that you just can't automate.
And all of this leaves us with one final, and I think really important, question to chew on. As machines get better and better at finding answers, will we humans get better at asking the right questions? The future of data analytics, and probably a whole lot more, really depends on the answer.